Thank you. My name is Michael Salin. I work for Microsoft. I'm a kernel miner. I'm maintaining Landlock. So this talk is both Landlock and systemd, how to use one with the other. But just initially, I want to be on the same page with everyone. We may have different definition of sandboxing. So in this case, it's about security sandboxing. So it was, it is really about what was the talk about this morning about security model for systemd. So in a nutshell, to restrict, restricted control execution environment that prevent potentially malicious software for accessing any system resources except those for which the software is authorized. So in a nutshell, by default, it should access nothing except what we want it to access. Landlock is an unprivileged sandboxing features provided by the Linux kernel. It's dedicated for this use case. Just a bit of context for Landlock. So right now it's being used by a few sandboxer tools. Like setproof, for instance, and also for developers, libraries, different languages. But most of sandbox applications are not using sandboxer tools. They are directly sandboxing themselves. So that is kind of not visible for most users, which is good for the security point of view. We don't have to configure anything specifically. We just use the application and this sandbox. So that's the base case. But that requires to change the application. So it is not free. We need to change that, and that is mainly intended for developers, owners of application of programs. So, what is Landlock exactly? Some key features, key properties. Landlock is an unprivileged access control. So by unprivileged, I mean in this case, the important properties are that it is dynamic and it is able to enforce ephemeral restrictions on a set of processes. This means that there is no persistent state. When a sandbox application is closed, the policy is gone. It also means that there is no remaining states on the system, so no need for file labeling and so on. So that's also useful and also required for unprivileged users, because you might not be able to change and to add extra information to files you don't own. Being privileged also means that you need to be able to have independent restrictions. So to have, let's say, 2 user sessions which are, each own sandbox with their own security policies. But at the same time, you may have nested sandboxing. So one user might be running in a sandbox environment, and this user might want to launch a new application that will sandbox itself and so on. So we need to support nested sandboxes as well. And all this needs to work the same way. So that's the main properties of Landlock. And of course, once a sandboxing security policy is enforced, it should not be simple to escape this sandbox. So at least not thanks to the kernel. So there are some implicit precision. We'll see just after that. Landlock is unprivileged access control, and by access control I mean be able to enforce security policy, to enforce restrictions on kernel resources. So that means to follow the kernel semantic. That means, for instance, files, sockets, network ports, UID, or whatever the kernel might provide, which is, for instance, not the case for seccomp. Seccomp is at the syscall layer, so it cannot difference pointers natively. And seccomp is not an access control system. It's still really useful, but it's mostly like a firewall for syscalls. Landlock is an access control, so it enables you to restrict access to files, file hierarchies, and so on. And all this might be, when you're thinking about namespaces. Namespaces are, very useful to do a lot of stuff in Linux, but they I would say, basic blocks to build views of the system. So you might want to mount file systems to set up network environments and so on. So you create views, and you might need some privileges to do that, even they are, well, unprivileged namespaces, user namespaces. In fact, it's not that simple, and not everyone wants to allow that because there's some risks for the kernel, because that wasn't designed initially for security use. So there are a lot of different access control in Linux. You might think about SE Linux, AppArmor, or LSMs. These are not unprivileged. These need to be configured by the system administrator, by the root user, for the whole system. So this is good and useful, of course, but it doesn't. It is not enough to sandbox applications, to sandbox code that you may not own, that you don't want to run as root, and as you know and want, I guess, you don't want to, if possible, have set-to-ID binaries on your system, so you don't want to give more privileges to be able to drop some privileges. And that's exactly the purpose of Landlock. So how does it work? Well, the principles are really simple. The idea is to restrict ambient rights, so when you launch an application, a process, it inherits the access right from its parent process. So most of the time, as a user, when you launch applications, it has all your access rights, and it can do whatever it wants. So it can access your SSH key, your GPG key, your private pictures, or whatever. And so Landlock does restrict ambient right, but according to the kernel semantics. So again, a file makes sense for Landlock. You can restrict access to file hierarchies and so on. And that's possible thanks to 3 dedicated syscalls. One to create a rule set, one to populate the rule set, and one to enforce the rule set on the calling process. And once a security is enforced, one rule set is enforced on the calling thread, every new process that will be spawned by this process will also be sandboxed as well. So there are mainly 2 use cases for Landlock. The first one I explain a bit is for applications that want to sandbox themselves. So most of the time they, well, you need to own the code some way or the other. And to patch the application, for the application to sandbox itself, to protect itself from external threat. So the idea is mainly to avoid exploitation of bug in trusted application. So trust here might be different. It might not be binary. You have different level of trust, but that's the main idea. So that fits very well for highly sensitive piece of codes, like for instance parsers, web browsers, and some system services that might be exposed to the network, for instance. The second use case for Landlock, the second main use case for Landlock is to be able to sandbox untrusted code. So that's a case where either you don't own the code, you cannot change it, or you don't want to because it would be too costly. And then in this case, you want to create a sandbox and launch, this untrusted or not so trusted application in this sandbox, the same way you can launch a container and launch an application inside a container. And in this case, what the candidates, I would say, are, sandboxing tools. We have some sandboxing tools already. Container names, like Docker, Podman, or whatever, but also in system services. So in this case, of course, I will talk about systemd. But first, let me give you a bit of an idea of what Landlock can do. So there are some set of implicit restrictions and some explicit access rights. So implicit restrictions are there to avoid a process to escape sandbox. So, for instance, if a process is able to ptrace a process outside of sandbox, it will be easy to, bypass these restrictions. So that's the kind of stuff which is probably done by default. You can ptrace processes in a same sandbox or in a nested sandbox, but not in a parent sandbox or outside of sandbox. Same thing applies for file system topology changes. So it means you cannot mount whatever you want. Otherwise, that could be a way to avoid some restrictions. But the important part is that you can have some explicit rules on the file system, docking on some IPCs to only allow access to some file directories or network ports, for instance. Landlock is evolving, so it started a few years ago. It was merged Linux 5.13. And so with new, or not new, not every new, but some new kind of versions, we get new features over time. So it's really an incremental development. And we get more and more features, more way to restrict processes to widen the scope of restrictions. And so with all these new kind of features, well, we can do more, but we should also be careful about not restricting too much legacy on, well, stuff that we didn't test it before. So that's something to keep in mind, to be forward compatible, but also be not to break applications with kernel updates in a nutshell. So, Landlock support for systemd. So why? Well, because systemd is pretty useful, and it's really an easy way to launch processes. That might be system processes, network services, or even user services that you may want to launch as an unprivileged user. There are already a lot of different things you can do with systemd. For instance, you can enforce seccomp filters, even AppArmor profiles. But as I explained before, well, these are not really designed for sandboxing as I explained. Seccomp can reduce well, the possibilities for process to do harm to the kernel or to other stuff. And yeah, AppArmor is pretty useful too, but it needs to be configured by the system administrator. So as an unprivileged user, you don't want or you should not be able to change AppArmor profiles freely. But Landlock can do that. And the idea is really to be able to enforce a security policy on service at runtime. So it looks like this. So there's a pull request ongoing. You can take a look. I will get you the link after that too. So that's a really simple example of a sandbox service. A really simple one. So you have, well, an application, in this case, the foo program, which will be launched. And we just add the Landlock config key with a path. And this path will contain a set of files that will define your security policy. So because it is a system unit, you can also use some other tricks to well, add more flexible and dynamic paths for these conversion files. So in this case, let's say this path contains 4 files. So that might be 2 related to 2 different kind of libraries and 2 related to different kind of programs. Because one program can launch another one. And, well, if we're talking about complex programs, complex services, well, a lot of different code might be involved. And that also might include different packages dependencies. And when we're talking about packages dependencies, we're talking about updates and how to keep everything consistent and up to date. So if you want to update the library A code, well, you also want to update the related security policy. Because the library, well, some piece of code might require access to the network, to some specific file path, and so on. So this way of kind of splitting some responsibilities and really minimal units of updates into dedicated files make it easy to package all of this in what your common packaging system. But if you want to just have one file, that's also possible, of course. So Landlock config, here's a simple example of a simple conversion file. So that's a TOML syntax, so really, well, it should be easy to read. So this one kind of showcase a few features. You can have a simpler one, of course. The first part here is only useful if you want to use access groups. I define access groups in this case with, for instance, the ABI read execute access right and the ABI read write right. So I need to define that because, as I explained before, Landlock is getting new features over time. And on an install system, well, you might get a kernel update. So you don't want to break your sandbox applications by being more restricted and too much, by getting too much restrictions. So the idea is with the ABI to kind of pin to a maximum set of known and well-tested access rights to make sure that even if you use this configuration file with a newer kernel that support a higher ABI level, so in this case I'm talking about Landlock ABI, yeah, this is ready to kind of scope and to make sure that it will work and will kind of ignore new features which were not tested. So if you want to support a newer kernel, just increment this ABI and test it with a new kernel, and then, well, we can commit that it will work and get the guarantee that it will still work. And of course, that doesn't mean you need to have a kernel that support Landlock ABI 4. You can have a kernel that just support Landlock ABI 1, for instance, and that will be also supported, and natively it will just enforce the best default security in this case. So that's kind of what is difficult to do in code and what is now being really easy to do with the configuration file. So yeah, in this case, I define a variable name LW, so which can, well, extend to free path in this case. Well, that's for this example, and it is used in here for the parent hierarchy. So in this case, you want to be able to read and write AV files which are beneath /tmp or var tmp or home user tmp. And you want to be able to read and execute files which are under, well, common system directories. Okay, and the idea is, well, right now that's kind of quite static, but if you think about that and about the ability to compose configuration files, well, you can define a set of variables in one file and all the other parts of the CWC in another file, and you can update them independently. So that can be very powerful. And the idea is to make it possible to have some other kind of variable. So for instance, to be able to read some environment variables to make this kind of security more dynamic. So some properties. The idea with all this configuration file is to make it easy to share, or possible to share and maintain securities. These securities are, well, these configuration files are declarative and deterministic, customizable with variable, or even without just adding well, different files or even symlinks to share files between different applications and so on. There's a kind of variable that can be used to make this static version more dynamic, and that, well, are designed to be easily and natively composable with different files. So we can define one variable in one file and the same variable in another file. It would just extend this same variable with the end values. And there are some predefined useful groups like read, execute, write, and all to restrict all or all. Some of the restrictions to, well, constraints to implement this kind of composability, of to be able to compose different parts of different snippets of security policies, is that, well, you need to make sure that it works, it always works. So, for instance, if one configuration file is designed for one ABI, let's say ABI 4, Landlock ABI 4, another is defined for Landlock ABI 3, then the composition of these two files should be kind of the same as a configuration file written for ABI 3, because only this one was tested. And what is really interesting about this way to compose files is that, yeah, you can share some of them. Distro might include them in some packages. As user, you might want also to provide some of them, or to override some values, and yeah, to mix everything together, which is pretty difficult with other kind of security policy systems. Landlock config is a Rust library, so it is written in Rust, but it has C binding and shared object for any C code to use, which is used in this systemd implementation, and it is well tested with a JSON schema and a lot of tests. So let's wrap up a bit. Landlock config, so that's the repo where the code is. So the project started this year, but I think it's pretty solid. It's not stable yet, but should be by the end of the year. You can test it without systemd, like this in this example, or with systemd if you go to this pull requests. So there's ongoing work to make this format more stable and most importantly future-proof. To continue the integration to systemd, so I just sent a pull request yesterday, so it's pretty new. And to be able to have more nice integration with systemd, for instance, to be able to have more dynamic security policies according to other values, which might be defined inside the unit files as well. So feel free to contribute to Landlock, either the kernel part and all the user space part, or even the systemd part, of course. Please take a look at the pull request, and feel free to say what you think about that. If you want to sandbox your own applications, there are some also some grants that might be a good motivation. And that's it. Thank you.
Do you have any questions? Oh, yeah.
Thank you for the presentation. Have you thought about having a policy, the config, a part of the binary itself, maybe like a node section in executable file or something like that, so it's, standalone or self-contained?
Yeah, it was suggested also. I think that would be interesting to do, and that would be possible with the same convention file format, just to embed that in dedicated section in an F binary. So yes, that's definitely a good idea. I guess the challenge would be, we'll need to have some code that will be launched before the main function, but that's doable, definitely. And that might be, easier to use and to just patch a binary without touching the code really. So yeah, that's interesting. But yeah, right now, the idea is to really to have a stable and future-proof convention file, and then yeah, we'll be open to extend its use case.
Any more questions?
Yes.
I didn't quite understand how you choose which one of the configuration files to apply where, or do they all just get merged, like for the different libraries and that?
Yeah, in this case, yeah, they all get merged. So that's what I call composition. So you take all these files. It is, in theory, it is like concatenating all these files, but in practice, it is not the same, because I have an example. I didn't have enough time to talk about that, but yeah, you'll find some other slides in online. In this case, for instance, I have two files, file 1, file 2. File 1 has support up to ABI 5, and file 2 up to ABI 4. So there are some complementary parts, but not exactly the same. And when we compose them, in a nutshell, we get something like this. So we get ABI 4 because that's a common lowest known and well-tested ABI. So we support up to this access rights, which are defined here, ABI all, so ABI v4 all, right? So we get everything here, and then we merge all the variables and everything in together. So yeah, that's merging files, but yeah, that's a bit more complex than just concatenating everything.
We're running out of time, but thanks again for your talk.
Thank you.